Now let's try our final example. In this particular example, we have a 1.7 gram compound containing chromium is converted to acidified dichromate, Cr2O7. Now the thing to watch out for here is dichromate has got 2 chromiums in it. The solution is then titrated and requires a 50 ml of 0.4 molar iron 2 sulfate. To reach endpoint, calculate the percentage of chromium in the sample. So just quickly, we've got, here is our diagram. We've got iron 2 in the burette. We've got 50 ml, 0.4 molar. And in our conical, we have our acidified dichromate, which is Cr2O7 2 negative. And we put in 1.7 grams of the chromium compound. Okay, so to start with, we're going to have a balanced chemical equation. Now this is a skeletal equation. We know that dichromate has to be acidified, so it's going to be in acidic conditions. So we break it into our 2 halves. We've got iron 2 ions going to iron 3 ions. And we've got Cr2O7 2 negative goes to Cr3 plus. Okay, this one here, the matter is balanced, just put in an electron. Now you can either balance it through ion electron method, or you can go to your data sheet, which I highly recommend, because then there's less likelihood of a mistake. And that's where I'm going, is my data sheet. Now, problem here is this has got 6 electrons, this has got 1, so we need to times this by 6 and add it together, and we end up with 6 Fe2 plus dichromate plus 14 hydrogen ions plus 6 electrons goes to Fe6 Fe3 plus 6 electrons plus 2 chromium ions plus 7 water. Eliminate and redo with appropriate state symbols. Okay, now we're ready to start. It says identify the known species iron sulfate and calculate the moles of iron 2 sulfate. So the number of moles of iron sulfate is going to equal the number of moles of Fe2 plus, which is equal to Cv. In this case the concentration is 0.4 times the volume is 0.05, and this comes out to 0.02 moles. Now it says calculate the number of moles of dichromate, so this is our unknown. So the number of moles of dichromate equals unknown over known times the number of moles of iron 2, which in this case the unknown for dichromate is 1, the known is 6, times 0.02, and this comes out to 3.33 by 10 to the negative 3 moles. Using your answer to part 2 above, calculate the number of moles of chromium present. So the number of moles of chromium will equal 2 times the number of moles of dichromate. And you can tell this from the formula. For each dichromate there are 2 chromiums, so it's going to be 2 times 3.33 by 10 to the negative 3, which comes out to 6.667 by 10 to the negative 3 moles. Next part of the question, calculate the mass of chromium in the sample. So the mass of chromium is equal to the number of moles times the formula mass, which is 6.667 by 10 to the negative 3 times 52, which comes out to 0.3467 grams. Last part, calculate the percentage of chromium. Percentage of chromium is the mass of the pure over the mass of the impure times 100. So the mass of the pure is the 0.3467 divided by the impure. If you go back to the top here, it tells us that we put 1.7 grams of the compound in, so 1.7 times 100. Now we need to check our sig figs. So this one's got 3, this one's got 3, and this one's got 3, so our answer should be in 3 significant figures, and it equals 20.4%.